Hello and good day. My name is Chinchevi from Group B4, and today I'll be presenting Lab 6, specifically Part 2 IC voltage regulators, Question A. So, for Question A, we have to construct a fixed output voltage regulator circuit, as given in Figure 6.48. We have to connect the 1 microfarad capacitor as closely as possible to the IC7805 regulator. So, this is the given fixed voltage regulator. Now I'll use multisim to simulate it. So first of all, we need this voltage source. So in multisim, it would be given as, well, I already have selected a resistor here, so let's place the resistor down first. So for in multisim, this would be the DC interruptive voltage. Okay. Next, let us select this LM7805. Selected. Now we need a capacitor, a polarized capacitor. And finally, we need a ground. Okay. Now, with regards to this voltage source, the maximum is 15 volts. So let us set it to be so. Maximum value 15. Now, as you can see, it goes from 0 all the way to 15. Now let's connect the circuit. Click Ctrl R to rotate the C1. And again, for R1, hook it up. Bring it as close as possible for instructions. And connect the voltage source. Well, this is question A completed. Now, the next member of our team will present B. Thank you for your time.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Mifan Mirostan. So today I want to continue about experiment 6. My part is part 2 IC voltage regulator. So my part is for question B. For the question B, adjust the DC input voltage V in to the regulator and record the output voltage. Vary the V in from 1 to 15 volt, which leave at least 10 measurement in between. Then record the table result and explain how the output change in the input. So according for the simulation, so I give for example, the voltage is I set 1. Then I run the simulation. So for the V in, we get 1. For the V out, we get the 0.0014. Next, if I set the voltage in 5 volt, then I run the simulation part. So for the V in, we can get the 5 volt, and for the V out, we can get 3.76959. For and next, if I set the voltage to 10 volt and I run the simulation. So for the V in, we can get in 10 volt, and from the V out, we can get the 5.00432. So next, for the 11 volt, I run the simulation part. So for the V in, we can get 11. For the V out, we can get also 5 volt. Why we can get 5 volt? So for the IC regulator, this is our part. We have measurement. So first, from start from 1 volt until the 15 volt as the procedure need. So this is the table we can look. So we for the column 1 is V source, column 2 is V in, and column 3 is V out. So we can see start from 7 volt until the 15 volt. The V out same or little bit change. Because for this experiment, the output increase in the input voltage increase, but the output become the constant after 7 volt. So after 7 volt, the output become constant. This is because voltage regulator device maintain a voltage of power source between acceptable limit. So for voltage regulator, limit for voltage is 5 volt. Okay, thank you. That's for me.
My name is Muhammad Zulfazar Fahmi, and I will show the graph for the measured output voltage versus the input voltage of the voltage regulator. So this is the table for input and output voltage. So I use Microsoft Excel to plot the graph. Okay, as we can see, when the input voltage is 7 volt, the output voltage is at maximum of the voltage regulator, which is 5 volt. Below the 7 volt, which is 6 volt and below, the voltage regulator will not exceed the maximum regulator. So that's all from me. Thank you.
Greetings to Dr. Nurmisa. So here I would like to present about my part. Question D says construct the adjustable output voltage regulator shown in figure 6.4b. Measure the DC output voltage for resistors value of R2 that varies from 47 ohm to 220 ohm. Compare the expected output voltage from pre-lap and stimulated output voltage value. So this is the circuit for the 47 ohm with the output voltage of 2.55. Next, this is the circuit with the resistor of 220 ohm with the output voltage of 9.68. So from the pre-lap for the resistor with 47 ohm value, we obtained the output voltage value as 7.579. The value of output voltage from simulation is 2.55. While for the resistor with the 220 ohm, the calculated value is 17.540 volt, while the stimulated value is 9.68 volt. This shows the difference between the stimulated values, which are smaller compared to the calculated value.